Hi friends, we are in chapter 7 and we're looking at polynomials. Today we're going to talk about the really necessary, beneficial, and helpful way that scientists often write numbers, scientific notation. And this is going to be a short section because I'm assuming you guys have seen this before. If not, don't worry, it'll still be relatively simple, and we'll talk about its applications in class and hopefully a couple times throughout this presentation. All right, so let's take a look. Our only vocabulary word today is scientific notation. And really what scientific notation is, it is a process by which very large and very small numbers can be written conveniently in a form of. So when you write numbers that are large or really small, all of them will be written in the same way. A, some number A, where A is between 1 and 10. So it can be 1, but it cannot be 10. So really it's like between 1 and 9.9, get it right, 1 and 10, but not including 10. So A times 10 to a power. And so that's something that I'm sure you've seen before. And actually you see it on your calculator. If you ever get your calculator, if you ever pick up a calculator, even a scientific calculator, one of the ones, $10 ones, and you actually calculate something like 2 to the 37th power or to something to a very large power, what you might see is something like this. You might see a number that is 1.6 and then exp 13, right? What that means is 1.6 times 10 to the 13th power. And that's a convenient way to write a really big number. And oftentimes the calculator would do that because it doesn't have enough space or enough digits. It can only show a certain number of digits. So with that in mind, we're going to go ahead and get some example problems done. So this first example problem, what we're doing is we're going to take large numbers and a small number, large number, small number, we're going to write it in scientific notation. Remember, we're going to have, the key is to have some number times 10 to a power. The number that we have is 201 million. And what we do is we would write this number by moving the decimal place over 1, 2, 3, 4, 5, 6, 7, 8 places back. So 2.01 is what we get. So notice we've made sure that our number is somewhere between 1, remember this is our A value, somewhere between 1 and 10. Now that we've done that, we need to compensate for what we just did. We just changed the value of this. So I have to figure out how many spaces I moved back, and I moved back 8 spaces. So what that means is I'm going to put an 8 here because that tells me to multiply 2.01 times 10 to the 8th power. That kind of makes sense. 10 to the 8th power, which is, what is that, 100 million? So if we multiply by 100 million, it makes sense that we would get multiply 2.01 times 100 million, we'll get 201 million. Yes? I'm hoping you like it. All right, so let's take a look at this one. We're going to have to make sure that the process is the same. We're going to write some number times 10 to a power, and we're going to figure out the power, and we're going to figure out what that number is. Notice now we're taking a tiny number and we're in essence making it larger by 1, 2, 3, 4, 5 movements of the decimal place. So now when I move it to 5 spaces, and notice I'm always moving it so I can create a number that's between 1 and 10. When I do that, what I see is that I've made a tiny number much larger, so I need to compensate. So now, instead of multiplying by 10 to a positive power, I'm doing 10 to a negative power, which means dividing by 10 a number of times. So this is like dividing by 10 5 times, or dividing by, what would that be, 100,000? Divided by 100,000, right? Sort of, everybody? All right, good. So that's what we have, and we've successfully changed these standard notation values into scientific notation values. So now we're going to take this example 2 and go in the opposite direction. So 6.32 or 6 and 32 hundredths times 10 to the 9th power is going to give us, so I like to literally start off with what I have and simply multiply through. 1, 2, 3, 4, 5, 6. I said multiply, I mean move the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9. So these little spaces I'm going to fill with zeros, which are going to be my placeholders. And then I realize that I have 6,320,000,000. I had to write that over a little bit neater. All right, let's go on to this example. So this is the standard form of this number. And over here, we have 4 times 10 to the negative 7th. And when I see that negative 7, I know that it's really small. So I'm going to start off with 4, and I'll move my decimal place and to the left. So 1, 2, 3, 4, 5, 6, 7. There's a decimal point there. I fill it in with my zeros, and this is the number I get, 0.023456, and there's a 4. So pretty tiny number, and that's writing our standard form. That's what we would do. Let's look at the next example that we have here. Example 3, we're going to multiply and divide with scientific notation. So here's our multiplication problem. We're going to first start off by, my suggestion is, let me see if I can get this screen to show a little bit better. Okay, good. My suggestion is that you take the A number, right? The number that we refer to as the A term in each of the numbers that you're multiplying. So 3.5 times 7, you're going to do that, and then you're also going to multiply 10 to the negative 3rd times 10 to the 5th. Notice I just changed the order, and you know we're able to do that with our properties of multiplication, right? So associative property and transitive property, I think, are the ones that we can use to kind of move things around here. And so with that in mind, this is really easy for us to do because we just learned our laws of exponents. So 10 times 10 to 10 to the negative 3rd power times 10 to the 5th power is going to be 10 to the 2nd power. Does that make sense? Because I'm adding my exponents. And then when I multiply these guys together, let's see, 7 times 5 is going to give me 35. 5 down there, carry my 3. 7 times 21, 22, 23, 24. So I have 2, 4. So I'm going to get 24.5 times 10 to the 2nd power, which is not scientific notation, and it's because this piece here fails, right? And the failure is that it's not between the value that we want, but we can totally compensate. Just going to move the decimal point over, right? 2.45. But now I need to take care of that here because I moved the decimal place over. I made it smaller, and to make it its original size, it needs to go up 1, right? Because when I move it to the left, I'm making the number smaller, so I need to compensate here by writing this as 10 to the 3rd power. So I added 1 to that power. Does that make sense? I hope so. You're going to let me know if it doesn't. All right, child. So let's go ahead and look at this next one. Similar to the example with multiplication that we just did, we're going to look at this example with division. And I'm going to handle this in a similar way. I'm going to take my 3.066 and I'm going to divide it by my 7.3. And then to that, I'm going to multiply 10 to the 8th over 10 to the 3rd. Okay, you guys know how to handle that again from the last section, 7.2. And so what we're going to do is just subtract these exponents. And then so I end up with 10 to the 5th power and 3.066 divided by 7.3, 0.42. So I'm going to get 0.4, sorry about that. I'm going to get this is not working. It's not working, children. It's terrible, just horrible. I tell you, just ridiculous. All right, let's try it again. There you go, 0.42 when I divide these guys together. So I got 0.42 times 10 to the 5th power, which is cool, but not that cool because it's not scientific notation. How do I fix it? I've got to move it to the right, which means I'm changing the value. So I'm making something that was smaller a little bit larger. I compensate over here by reducing the order of magnitude or the power up here. So I get 10 to the 4th power. Does that kind of make sense? I could do this a different way. We'll talk about it in class if it's not feeling right, where let's go back to what we had here. I had 0.42 times 10 to the 5th. I can look at this and write it as 4.2 times 10 to the negative 1. Could you get that? Because I just moved it over. But I'm also multiplying this times 10 to the 5th. And therefore, to the negative 1 plus 5 is going to give me 4. I don't know if that feels right. I did that last year with one class, and some kids felt like, yeah, that was good. And other kids were like, what? So if it makes sense here, when we just talked about it, like when you have to take this number, let's go back to 24.5, and you realize you're going to make it smaller to fit the model of scientific notation, you're going to have to compensate by increasing the power here. Over here, we had to make this larger than it originally was. The 0.42 was made larger by moving that decimal point over. Then we have to make this smaller by moving it down to compensate. Does that make sense? I keep asking that. I guess you'll tell me tomorrow. All right, let's see. I think that is it for our examples. So I'm looking forward to talking to you guys. I'm looking forward to hear what you have to say, and let me know. All right, it's always a pleasure. Looking forward to seeing you tomorrow. Take care. Bye-bye.